Welcome to video number, 19, about how to write a chess program in Go. And today, if everything works as expected, we will start to play a game. Terrible, but play anyway. We just need to make some little more coding. We need a search to start with, and we just built a search function that doesn't do anything special. It calls the evaluation of the position. Maybe bored, but we keep it close here for now. And the evaluation, we will come back to that. In the rote, we will generate all the moves, evaluate and sort them, and for each move we will search. We say score is the value from search, and we store that in the move. We have space for that. Okay, so let's take a look at the board again. We will use something called piece square tables, so I will show how it works here. If we take the knights, for instance, they don't like to be on the edge of the board, and definitely not in the corners. In general, of course, in general. So the red lines here tells us that the knight doesn't want to be here. The knight wants to be close to the center, and every piece wants to be close to the center or threaten the center in some way. Except for the king, of course. So the blow lines here represent center lines and center files and the center squares. But the king doesn't want to be there, of course. The king wants to castle, come close to the corner. Okay. Now I have make some preparations. And I have also made these piece square tables. So let's take a look. There it is. And if you look at the, you can see it's divided by files and ranks. So here is score for the knight on certain files and on certain ranks. And I do the same with kings and pawns and the other pieces. And the piece square table is 12 pieces and each 64 squares. So I initialize this table with very simple. I just add the file value with the rank value for pawns, and do about the same for every piece. A little bit different maybe for rooks and queens and so on, but in principle this is what we have. So every piece will have a point for a score for each square. And then I put some bonus for pawns on the center squares and bishops on long diagonals. And we also do the same for black pieces, of course, but they will get negative values. And we mirror the square and give them negative values. So if we have a completely symmetrical position, all the scores will add up to 0. And the piece score, p-square score, is the piece on a certain square. Every score we have should be compared with the value of a pawn. A pawn is 100, and everything else is related to the value of a pawn. So a pawn is 100, the white pawn. The black pawn is -100. And all these p-square table values will be about 10 or -10 and things like that. The knights 325, bishop 350, rook 500, queen 950, and finally the king could have any value, but we put a very high value for them, even if the king cannot be captured. But we will have use of this for other purposes later on. And remember that these values, piece values, are not written in stone, except for the pawn value. We keep that to 100, or it could be 1000 or whatever, but that is a fixed value, and everything else is related to that. So 325 and 350 for knights and bishops, it can be discussed and actually should be tested. But I have written chess programs before, and I just pick these from my memory. So evaluation of a position will go through all the squares from A1 to H8. And is it empty, we go on with the next square. If not, we take the piece value and add that, and add the piece square score, and that is our simple evaluation. And if you look at all the to-dos up there, they represent things that we need to do with the evaluation function to make it at least decent. What we have now is not good, but good enough to start with. Okay, so the rote, our rote function, let's adjust the square a little bit. So the rote function we loop through commands. It's the go that we get, start to think. We have an empty move list, and we generate all the moves and sort them. So if we look at that function down here, so we generate all the moves, we go through all the moves, we make a move, evaluate the new position, and unmove, take back the move. And then we store the score in the move. And finally we sort the move list. And how can we use that? Well, in the rote we go through all the moves, we make the move, and we run search and get a new score. It's important to have the moves in a good order, so that's why I do all this sorting. So we get a new score, we unmove, and we put that score in the move, and we sort again. And we need to tell the GUI something about the score and best move and things, and the depth. And CP here means centipoints, so that is the value we send. And finally we send the best move to the channel, because we have a special treatment of best moves. It's time to play a game. So we open SCID and a new engine, GoBit, and we pick up from somewhere in my projects, Go project, Go bit down there, and there is the program that we will use, and the rest is okay. I think we could configure with things, but we really don't use that yet. And let's put GoBit after Stockfish and Komodo, where it belongs. We don't actually play against it, we use the analysis that we get. Okay, so E4, let's make that. And he say, okay, you should make E5 and get 0. The score is 0. But let us do something else. E6. And then he said, make knight F3. Okay. But we make D5. And then he said, oh, look, I can win a pawn, because there is no look ahead. So he doesn't understand that the pawn will be taken back. So he takes the pawn, and we take back, and we make knight C3, and we do C6, and here comes the first really funny move. I win a pawn, knight takes D5, and he thinks he wins something. And here we take it back, and he makes rook B1. We can do knight, we can follow what GoBit says. Knight F6, D4, knight C6, bishop F4. And he takes the pawn and the rook, whop, and we take, yippee, we win the knight, but lose the queen. And as you see, it takes everything, captures everything it can. I think we can stop here. It play, but maybe not the best game we have seen in our life. So let's stop here, and no one want to save this game. That's all for today. We have a program that plays something that looks like chess, at least. We will continue next time with to make it better, to play a little bit better. Okay, until next time, bye bye.